Hi everybody, in this chapter we are going to talk about the interest rates, how we determine the interest rates. We are going to talk about concepts like term structure and yield curves and how to estimate the future interest rates. Now, there are four main factors that will affect the level of interest rates. The production opportunities, kind of like the demand for interest rate, time preferences for consumption, risk, and expected inflation. We are going to cover each of them one by one, but let's start with nominal versus real interest rates. Nominal is basically if you deposit $100 to a bank and if you're earning 4%, you are getting $104 at the end of the year. That's kind of like a nominal term. Real is pretty much when you are giving somebody, let's say, 100 ounces of gold and receiving 104 ounces of gold. Gold is not a great example, but that's exactly real. That's the real interest rate, assuming the prices do not fluctuate a lot. So nominal is pretty much tied to the current pricing environment, and real interest rate is actually the real purchasing power of the interest rate. The nominal interest rate is pretty much the real risk-free interest rate that you are getting, the real rate. On top of that, you add the inflation premium. There is always some type of inflation. Then you add your kind of risks. One is the default risk, the risk that they may not pay you back the principal. The liquidity premium and maturity risk premium. Now, in short-term treasuries, the only pretty much premium that you have is the inflation premium. That is pretty much it. On the long-term treasuries, on top of the inflation premium, you are going to add maturity risk premium as well. So it's kind of like longer term. That's why the risk is higher. On short-term corporate, you don't have maturity, but you have inflation premium. You have, on the corporate side, corporates can go bankrupt, so there is default risk. And corporate treasuries or corporate bonds of debts, or when you are trading, they are not usually liquid as the treasuries. So there is liquidity premium as well. And on the long-term corporate bond, you have pretty much all the premiums, inflation premium, and the risks involved. The maturity because it's long-term, default rate because it's corporate, and liquidity because again it's corporate versus treasury. Now, what yield curve means is when you start plotting the number of years to maturity, and when you start plotting the interest rate that you are getting for a 1-year bond, for a 2-year bond, for a 10-year bond, and for a 30-year bond, you are going to get what's something called the yield curve. And yield curve's regular usual curve is something like this here, the green one. But sometimes the yield curve can be just flat or can be inverted. And there are different hypotheses and descriptions why they can be converted. And the reason why I say this, the green one is kind of quote-unquote normal, is because when I go back to long-term treasuries, you are basically adding the maturity risk premium. So the longer you wait for maturity, you are demanding more interest. That's usually the normal case. But in the case of expectations where you expect different inflation rates and different time periods, these curves can be inverted, just like the blue line here. Now, in order to construct the yield curve, you need to find the average inflation to find the inflation premium. And it's given here like what the inflation premium for 1 year is, for 10 years, and for 20 years. You are going to calculate maturity risk premium, and it's kind of given you in a formula. It's not the only formula for maturity risk premium, but it basically tells you that over time the maturity risk premium should increase. And you are going to assume that the real risk-free interest rate is 3%. Then you can calculate, okay, my risk premium, the interest rate for 1 year bond is going to be 3%, the real one, plus the inflation premium, and there is no maturity risk premium, so it's 8%. You can do the math for 10-year bond, you can do it for 20-year bond. This is all hypothetical. Again, it's given in an example to show you that the normal curve will look something like this blue line here. So there is a risk-free rate, that's baseline, and then there is inflation premium, and then there is maturity risk premium. What this shows is, as you get more riskier investments, a AA rated bond is fairly safe, but not as safe as treasury bonds. So it's riskier compared to treasury bonds, but safer compared to BBB rated bonds. So what you're seeing here is, for the same maturity, if the risk increases, the interest rate you are demanding on that bond is increasing. There are different theories explaining the yield curve, so I strongly encourage you to read those and make sure that you understand. The last piece I want to underline here is, if you are given a specific curve, a yield curve, 1 year is 6, 2 years is 6.2, it increases just like we expected. It has this nice shaped curve. And the question is, what is the interest rate? What is the expected interest rate on 1 year treasuries 1 year from now? Now, what we are trying to calculate is between, if I want to do a timeline, if I do the timeline something like this here. So I have a timeline, and my year 0 is right here. The interest rate for this one is 6%, and then what I'm trying to calculate is the 1 year interest rate 1 year from now. So between year 1 and year 2, what is going to be my interest rate, given the 2-year interest rate is 6.2. What you are going to do is, you can take any principal, $100 or $1, it doesn't matter. If you take $1, it is going to be 1.062 in year 2 and 1.062 squared in year 2. Take that and say, okay, if I invest the same amount in year 0, I'm going to get, from a 1 year bond perspective, if I don't do this type of jump and instead do, okay, I'm going to get 6% first, and then what am I going to get next? If you do that, you are going to see that in this year, particularly from year 1 to year 2, the interest rate needs to be 6.4%. The idea behind that is to calculate what the 1 year interest rate is going to be a year from now. If, again, and going back to this particular example, if the 2-year bonds is earning 6.2%, so you are going to earn 6.2 and 6.2, so you are getting 1.062 squared, is going to be equal to what you are earning in the first year, 1.06 on a $1, multiply that by 1 plus the interest rate, and you are solving for that particular interest rate. And this has to be 6.4 to make sure that the markets are efficient and you are basically not gaining or losing any money, whether you invest in this type of scenario or whether you are investing in this type of scenario. That is pretty much the idea behind the forward rates. We are going to talk about the forward rates after the midterm, but that is pretty much it I want to cover for interest rates. I hope the example helps, and what I want you to do is, I want you to calculate the 3-year security 2 years from now example as well. You need to understand the mechanics behind that, so make sure you go over that example as well. And that is pretty much it for this lecture, and I will talk to you for chapter 7.